This is the Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known.
Hello, I'm Lee Bordens, and it's Wednesday, May 15th, 2024. Welcome to the Math Map Book Club, where Kirsty Gilpin and I discuss lessons each week from our math curriculum for families with students enrolled in classical conversations. We are currently in our summer session and working through the curriculum by dimension rather than by lesson, so we can discuss resources and strategies overall in math education. So Kirsty, what do you have for us today?
I think you're muted.
There we go. Sorry. So today we're going to be looking at a lesson from the second dimension and talking about what math looks like at your family table. So we've had several people who have asked the question about what do we do when I have multiple ages? How does this work together? So before we do that, I wanted to share something that came up since last week. Last week we were talking about computation practice, and I had another conversation this week about that. Something I said I was told I should share here. So when we think historically of computation practice and why did we drill so often, there's really two reasons. One was to develop fluency, right? The more that we practice, the more fluent and familiar we become. But the other reason is that the more we practice something, the more likely we are to notice patterns. And so for students who are not being trained in those classical skills of learning those our core habits, our common topics, and our canons of rhetoric, for those students who aren't being trained to learn and look for patterns, they need a lot of repetition, right? We have to experience things many times before we stop and go, I've seen this before. But for students who are being trained to memorize or to compare and define and consider the circumstance, to look for authority and testimony, to look for patterns and then explain why those patterns hold, they may not need quite as much repetition. And so I'm not saying repetition isn't helpful. I'm not saying you shouldn't practice computing a lot. But when we look at the math map, one reason why students may not need quite as much drill work as a traditional curriculum is because they're learning that alongside being taught how to look for patterns, how to ask good questions that are going to help them to see those patterns without sort of having to do something over and over and over again until it finally clicks. So I just thought I would share that. And then before we jump into talking about the family table, are there any questions that anybody has for us today? All right, well, we'll go ahead and jump in, and then if you have questions that come to mind, we'll have time again at the end. So as I mentioned, we've had several people that have asked us, what does this look like when I have multiple students at home? And how do I pull those students together? And so we're calling this math at the family table, right? Where we're all sitting together, and we've chosen these three levels. We've got our naturals, our fractions, and our complex levels up here on the screen. These are all from lesson 11, which is about curved lines. And it's really looking at most of our functions. We're going to be looking at power functions and exponential and logarithmic functions in lesson 11. Something that students may not normally see until the latter half of their high school algebra experience in a traditional curriculum. So let's think about if we had sort of a 6-year-old, a 9-year-old, and a 12-year-old sitting at the table together, how can we use, and we're going to go through all of our different skills and tools of learning, but how could we use our grammar skills, our core habits, in order to load that grammar? So take a look at these, and what are some things that you could ask your different age students to name?
What domain are you in?
That's a great thing, right? So first, making sure our students know what domain they're in. And that's tempting to overlook. I love that you said that, Lee, because we may initially just, right, we pretend those colors don't exist, and we zoom into those exercises, which is what we talk about every week. That's what we've been conditioned to do, is to go straight to the exercises. But pulling back out and talking about, what color do you see, right? What domain are you in? What are some other things that we could name?
Are there any things on this page that you know what they are? Anything that are familiar? Any terms?
Yeah, because I'm looking at these 3 pages, whatever age I was, I would probably say, can I do the bottom?
Right?
That's great. So what on the bottom? Let's look at how those things change on the bottom. What is something um, that is on the bottom of each one of those? And how could our youngest students perhaps name it? How might our older students, right? Well, how is the same phrase on the bottoms of all of these? And how could our different students interact with that?
I love the inflection point is in all 3 of them.
Great, Donna. So for our natural students, right, it might be that we read it to them, or one of their older siblings reads that to them, and then they can point to it. What does our fractions level student have to do with the inflection point?
Identify it, figure out which one it is.
Great. So they're not, it's a step up from reading, because now we're matching. If they're working together, if their youngest student has that image of the inflection point, could that help that fractions age student to know what the inflection point is? So by comparing those two, which letter would be our inflection point?
Would be C.
C, great. And then how about our 12-year-old, our Challenge A student?
It's
What are we
labeling.
asking them? It's labeling.
Yeah. So it's the same thing as the fractions, but I just have to write out the whole word.
And I need to note that the word bank is in the instruction. So sometimes the
Right.
word bank's in the instruction. Sometimes we say word bank and we list it for you. And sometimes the words are near the image. So they could be, so it forces you once again to read what's in front of you.
I just love that the 12-year-old could say, oh, shoot, I forgot what an inflection point is, and look at their younger siblings, and the younger sibling could help them answer it. It's not always the oldest is going to have the answer. Like I'm told my families, I'm like, the lower the level, the more likely that more instructions are there. And so your older kids are going to be looking at your younger kids for the answers rather than the other way around.
That's good, Donna.
So what's something that we could attend to on these pages?
Well, the complex one still looks a little scary to me. And the exponential, the fraction, naturals looks pretty easy. That's just some trace. So I would probably want to attack the middle of the fractions and try to see what is that saying.
So what are you going to attend to? What detail are you going to look closely at on that page?
That there's still repetition within that column.
Okay, great. So looking for that pattern, attending, right? And going, okay, I think there's a pattern here. That's good.
You talking about the f of x across, then the f of 1, and then each of the steps? Is that the pattern you're seeing?
That's what I was
Well, I'm
thinking.
seeing the common fraction vertically. So it's vertically kind of working through the same thought. So it's not 12 different questions. It's three being described.
Yeah.
Lee, going back to even before we focused in on that, right? If I am asking my students, right, we're talking about this together, maybe, right, maybe this is, we're attending to some things before I send my older student off, or we're looking at this, just what you said, right, as they look at these pages and they notice if I attend closely, I'm attending to the fact that my graphs, right, I have these same graphs on all 3 pages, right? And that I'm tracing and tracing, but there's more detail. And then there's more. So those are some things we can attend to, right? Are the graphs, if we look at that, are the graphs are the same on each 3 pages, but are they the same as each other?
That's what I was going to say. The top row graphs, you could compare to the bottom row graphs in the fractions especially, and see like the middle one is horizontal, but on the lower side it's vertical. So just noticing those differences.
And maybe just spending the time describing what you have in front of you, and that the arrow on the left goes higher or goes up or whatever word the child wants to say, but on the right it's more vertical or it's going towards the axis, you know, whatever words they know.
Well, I've
Yeah,
also noticed that
Go
in
ahead, Donna.
naturals, row 1, 2, 3 equates to column 1, 2, 3.
Good. So that attending is looking at that detail and describing what we're seeing, right? And so just talking through those graphs and saying, what is it that you see? Can you describe that? How about, let's look at these pages and see if there's some things, what might your youngest student memorize? What might your fraction student memorize? And what might your complex student memorize?
I was thinking I'm more the younger student in this, but I was thinking I love the illustrations at the bottom, like the concave and the going up and down. That's so simple, because it gives me a picture and it gives me an image to associate that with. I love the igloo and the bowl. That's very appealing to me. So I would be helping them memorize concave up, concave down, and maybe we'd get a bowl and we'd do it on the table, or we'd run around the house and find things that curved up and curved down. So that is yeah, for my level, that really appeals to me. So definitely the word concave and just finding that. And then of course you can use the exponential and base because they're right there and you're tracing them. So you can just be talking about, like, what do you think when you think of that word? And what does that bring to mind? I think it's so clear. I just love that first page. So it's not crowded and it's very good. Thank you.
Mm-hmm.
That's great.
Well, to piggyback off of Amy Jones, the maximum and minimum would also be a thing you could do some hands-on things with the fractions level or even the complex level students for them to memorize.
Great. I think it's a great example. The things that you're pulling out are great examples that what we memorize may not always be, you know, here's an equation, memorize this, right? Or here's a written definition, memorize this, but it's building up that memoria. And so spending that time to say, do you know what concave up is? Or concave down is? Well, describe that, right? Or think of this picture and remember that with our older students, right? Describe this and remember what I mean. I think that's a really great example that when we're thinking about memorizing, it may not always be, you know, formulaic or very clear, but we're helping our students to build their memoria when we ask them to memorize something. Does anybody want to take a stab at something they could express? You guys kind of sort of did that when you talked about going around the house, but what could we express? Or does anybody want to tell a story from these pages?
I mean, you could look at the tiger problems and talk about the zoo, or you could look at the tiger problems, and the estimation problems are kind of interesting to me because when you read a chart, very oftentimes with exponents, your beginning or your ends are not good data points. So you could look at and say, well, if we looked at the year 3000, according to this graph, there's not going to be any tigers left. But does that have to be true? And then Kirsty would talk to you about limits on there. And then if you estimated the population of tigers at year 0, so going the whole way to the left, apparently there could be an infinite number, or you could draw the curve and maybe say there's going to be 100,000 originally. But we know that it's nonsense at both ends. Nobody knows. We're just guessing. So then you can talk about extrapolating data like that when you're trying to talk about the Earth being 1 billion years old, or the size of the universe. And that there's just all these presuppositions in math and science. It's not always gray. It's not always black and white. So I just told you a grown-up story.
Well, the math is accurate, but how we apply it to the science. Yes.
Yeah, it's usually the extrapolation of data that gets you in trouble.
It does indeed.
You can bring back your aunt friend from other places and have him, tell the story of how he increased and he went over the igloo, and then he was decreasing or going down and under the bowl, and just tell this story of an ant going up and down in different curves and different ways he would do that.
Great. Terrific. So remember that when we talk about the math map, our first thing that our goal is to see the unseen. But as we think about what we're teaching our kids mathematically, our goal is first and foremost to learn the language of mathematics. And so in order to do that, we have to load that grammar and take the time with our students, right, to name things specifically, to attend to the details, to memorize what things are, the meanings of words, and then to practice that through expressing and storytelling. And that's going to work for all of our students, right? That our Challenge A students, even if they've been doing the math map for several years, our Challenge A students are still going to have new things that they can be naming and attending to and memorizing. And so as we sit at the family table and we look at these, those are some ways that we can bring all of our students together into that conversation. Anything anybody else would like to share in terms of our core habits or loading the grammar?
I would just like to suggest that, if your child looks at this and reacts like some of us have, is to say to them, okay, first, was there anything you like, Mom, I just can't do this page, is to help them and say, okay, well, first, is there any gray that you could have traced? The second thing, is there a problem or two you could try? And then third one is just read the instructions out loud. Now you're done. Right? Always show them there's always something you can do, and do not give up, because that's a lesson for everything you're part of.
I was just thinking that storytelling, Kirsty, just helps you kind of solidify it in your head. Like it gives you an example that you can hold on to, because I can think of concave down when I think of that ant crawling over the igloo. And somehow with my mind or children's minds, that storytelling is like a communal thing. It's something that you share with someone else, but also gives you another type of peg to hang that fact on that has a high interest. So, and that has an imagination that you've attached to that. You've already invested in it, so to speak, in that idea, because you've created a story about it. So I think that I like that part of including that in math. It's better than those word problems that I used to suffer through.
You're just wanting to make up your own, Amy.
That's great. All right, so we've just talked about how all of our students are going to use their core habits to be loading the grammar. And once we've got some of that grammar loaded, our next goal is to start connecting that grammar. And we connect that grammar through our common topics. And when we think of that, we're thinking of comparing, defining, looking at circumstance and relationship, and authority and testimony. And so let's take a look at those same pages and think through what could we, and again, this is what we're doing at the family table. So there may be things that we might ask our Challenge A students to do independently, But as we're sitting together at the table, what are some things that we could compare together? What could even our youngest students compare? What could our oldest students compare collectively?
On their own page, they can compare the lines or the curves that they see on the graphs to the curves that they're seeing on the bottom.
Good.
A student in naturals could compare their graphs and see where they see it on their siblings' pages.
Good. So we can certainly compare across.
And it stands out more on the natural page, but each of the curves goes through the point 1, 0, 1. So that relates to your information on the left.
Okay. Could we compare looking at, when we look here, we've got the base is a different base each time, right? And we could look and see if on our other side, right, where we have some different definitions for base. And right, so we've got our base is less than 1, equal to 1, and greater than 1.
Yeah, just that fractions is an older version. It's been
Okay.
cleaned up to look exactly like complex headers.
So those headers are the same on all of our pages. And how do they compare to the graphs? Do they always look the same? So if my base is between 0 and 1, how does that graph look? Is that always the case? If my base is less than 1 and I come over here and my base is less than 1, does my graph always look like it's going down to the right?
Yeah.
Right. Right. So there's a great thing to compare, right? As we notice that's on all of our pages. Now for our littlest students, right, they might just go, well, when the base equals 1, it's a straight line, right? There's my base equals 1, it's a straight line. My base equals 1, it's a straight line. My older students might start to go, well, heck, I'm seeing the same thing on all 3 pages, that when my base is less than 1 or between 0 and 1, it's decreasing. When my base is greater than 1, it's increasing. Right? And they may, right, my oldest students might want to start thinking through, why is that true? But when I'm looking at all of my students, right, there's something that we can compare. So let's go ahead.
I'll say something that's fundamental is we talk about increasing and decreasing, but I mean, I had this question for you: increasing or decreasing in which way? They're curved, they're doing both. And we've put into the curriculum, and they practice it actually in an earlier lesson, that you always read graphs from left to right. So then you're increasing and decreasing a standard.
So how about definition? Is there something on this page that you think, oh, that's something that we could define?
Base.
Okay, how would you define base?
It is oh gosh. This is not going to be a child version, but it's the number that is raised to a power, or
Sure, it's the number, right, that has the exponent. And so here's a great case where we can look, I'm just going to circle this, right? So if we look here, right, helping our students see, well, there's my base, and we can see it over here, right? Here's my base, and the header, we'll see it in fractions too when that's been updated. Since I don't have the latest and greatest, that we're going to be able to see that our students, even if they're not maybe using the words we would want them to use, right? Because we're asking them to define it, not look it up necessarily. So we'll notice it's always the number that has the exponent. That's my base. what kind of a function are we talking about on each of these? If we look at the top bar on that page, not the very top, but underneath that,
Well, this would be a
Exponential
moment,
functions.
right, where
exponential,
the
right?
naturals could answer.
So my natural students are tracing that, so we could help them read that and then have our other students go and notice that they're looking at exponential functions too, right? So there's something else. There's another possibility for defining, right? We could say, well, the exponential function has what kind of exponent? If we look at this, right? So what kind of exponent is that? Is it a number exponent?
The letter.
It's a letter, right? So my older students might recognize that as a variable, but all of my students could look and say, well, it's a letter, right? And you could tell them it's a variable, or you could just leave it as, hey, it's got this letter there. That's a little bit different to some of the other things that we've looked at where we have numbers as exponents. Now we have letters as exponents, right? And maybe that's related to this idea of an exponential function. When we think of circumstance, right? When we think of circumstance, we're thinking in terms of the conditions that are around something that may determine something. Does anybody see things on this page that might be a good circumstance question to notice?
Well, your circumstance on the 3 different types of bases. And if you look under base less than 1, you get a fraction. If you get base equal to 1, you have 1. So 3 over 3 in the fractions level would be 1. And if it's greater than 1, you have a fraction and or a decimal or a natural number, depending on the lesson, that's worth more than 1. So the circumstance of what your base is, but that, so even though your base has 3 different circumstances, again, picking on the fractions in the middle, what doesn't change is how you add the exponents. You do this exactly the same way, no matter what the base is. And so that's what they practice there.
Great. So we can look, so notice that there could be things that we compared earlier, and now we're saying, well, let's call them circumstances, right? So things aren't off limits once you use them once. We can continue to use those ideas. How about our ants? Under what circumstance would our ant walk up before he walks down?
Using your base as a circumstance, you mean?
Well, I was
Oh.
just looking down at the bottom,
Oh, the
right?
bottom.
So look at the bottom of the page where we were talking about our ant walking along our curve. Under what circumstance would he have to walk up before he walks down? When it's concave
Down.
down.
Mhm.
And under what circumstance would he walk down before he walks up?
Gave up.
Concave up, right? So we can, there we go. We used our storytelling, but we're also looking at circumstance. So with
Well,
our,
it's in your bottom one on the left with the mountain, he does the opposite, is in the sense of how he starts. So that gives you a place to talk about what stays the same as what you just said. Is it up or down? No matter where, because he could have started at the top of a hill or at the bottom of a valley also.
how about relationship questions? So when we think of relationship questions, we're usually thinking of things in order or cause and effect. Does anybody see a relationship question you could have with your students?
And the greater than and less than symbols are just relationship in themselves. So any of those can,
Great.
and then actually doing it, playing that with the numbers, can we fill in the numbers for, where would they go? Would they be base? Would they be, what is it?
Good. I love that you just said, so we just pulled in where we compared and we saw that there were 3 different types of right possible ranges for our base. And then we talked about how those can be our circumstance. And now you're saying we can use those to talk about the relationship and order things. So I could even just giving my student a number, right? Let's say I said, well, what's 1/2? Which circumstance would that go in? What's 5? What circumstance would that go in? With our older students, I might want them to take that a step further and say, okay, if my base is 1/2, is my graph increasing or decreasing? If my base is, right, if it was 7, would it be increasing or decreasing? So I can use those relationship questions with my youngest students just to compare, right, and know what order my numbers go in. With my older students, I might push them a little bit farther and say, okay, well, what impact does that have on my graph, right? And so looking at those relationships. And then how about authority and testimony?
I think in math, it's sometimes fun to say, can we find a different authority that agrees with this?
Oh,
You know, where else have we seen this? Have we seen this somewhere else? Do we just blindly believe this curriculum developer? Or do we want to find out? Can we Google it and find out that this is true?
Mhm.
Okay. Could you look at other weeks, other lessons? What
Yeah,
other
that's what I was
lesson?
thinking, that multiplication of 1, like that, no matter how many times I multiply that 1, like it's stable, just like we have in this visual.
Great.
Yeah, and Melba brought up the base, and she did a good job of trying to describe it when there's actually no definition on these pages. But if you had gone back to weeks 7, 8, and 9 and 10, no, not 10, you would have seen base being used in those 3 lessons with definitions and getting, more and more information. And then, of course, there's the charts. And Donna put in, I think, or Babs, the glossary.
Great. So we have outside resources that we can use, other lessons, the glossary, the charts, right? If you want to go outside of the math map, right? So looking for those things that agree or give us more information as an authority and a testimony. Are there any things on this page, like just on this page, and with my older students, right, I might have some authority types of questions, right, when we think about our tiger problem, just as Lee pointed out, right, this only works for this sort of smaller interval of dates. It doesn't work for everything. So is that model an authority forever, right? Does that work for all time? Or does that model only work for a limited amount of time, right? So even on this page, we could talk about authority and testimony and what's true.
I mean, I think it'd be interesting to ask your child to say, look, in 1970, you're supposed to, this chart says you're going to probably answer around 40,000. Can you go get the World Book Encyclopedia and see how many tigers there were? And just for FYI, when we did word problems, we tried really hard to go get good data.
So that's a great, so there's lots of things when we talk about authority and testimony, right, that we can point students to. And Donna, I like what you said about, right, don't just trust it because, somebody wrote it, because they could make a mistake. And I always think about when I was teaching Sunday school, I would always say to the kids, like, just because the pastor says it, right, don't just rest on that. We always want to go back to the ultimate authority, right? We always want to go back and say, what did the Bible say? Right? Just because I say it as your Sunday school teacher, I might be wrong. So you want to go back and you want to see what the Bible says. And so even with our young students, right, we're training them up to, I like that phrase, like be like the Bereans, right? And don't just accept things that people tell you, but be sure of it for yourself. And that's okay for our natural students as well as for our older students.
So Chrissy, I have a question. I know when we first started working on this, you had concave down and concave up in the charts. And I was like, well, how does concave relate to convex? Well, in polygons, that was very clear. but I wanted to know, how does that relate in functions? So that would be the kind of question that I could go ask as a parent, who might go, wait, is this really, adding to your own information as to the circumstance when you would say convex versus concave up or down, if it changes or not. And then just so you know, like the ant, we have a bear that's in the convex shapes. He hides in the in the concave shapes because he's in his cave. So we're trying to give things that they can hold their, hang that thing, images they can have pegs with, so that as the pegs disappear, they might go, wait a minute, this is just like the bear problem or the mountain problem in this case.
So let's go ahead and now extend our conversation one more step. So we're going to load the grammar. That's always what we're doing first, right? Because we can't connect the grammar if they haven't loaded it. So we want to load our grammar using our common habits, or I'm sorry, our core habits. We're making connections using our common topics. And then when we want to share that, right, we're going to share what we know with somebody else. We are going to use our canons of rhetoric. We're going to have things in our memoria, right? So that loading our memory, loading our grammar is really important, because I can't pull anything out of my head if I never put it into my head. Our invention helps us to pull things out, right? It helps us to ask those questions that pull things out and then eventually puts them into order, right? Into an arrangement. And then when we think of elocution and delivery, we think of, in math, right? Elocution is that idea of sort of style. We're not really going to be stylish with math, although math can be stylish. But we want to make sure, are we answering the question that was asked? Are we using the appropriate units, right? Did I come back and just answer a part of it, or did I give the full answer? And then my delivery, am I presenting my work clearly to somebody else? Did I show all my work? Is it neat? Is it organized, right? How did I deliver it? So sitting at our table, right, how might your older student use some of those canons of rhetoric to share something with your younger student? Or is there something that your younger student might share their knowledge with an older student? And how can we be introducing them to these canons of rhetoric?
Well, they might be noticing the arrangement and then have a question, like for instance, on fractions, why is my vertical line 1 above the axis versus in complex, why is my vertical line 2 above the axis, looking at the constant. So just the graph's arrangement's different. And then the way the asymptotes stand out, that arrangement's different. I would ask, and I know this has been cleared up. We keep fighting with these graphs. They're really quite difficult as they approach the axes to get them correct. And so if you look at the fraction on page, the naturals graphs, they run into the axis at the top and the bottom, but they don't run into the axis over here in complex. They approach it. So that means they need to be drawn better on the naturals, and they are. But these are the things that like catch my eye when I'm comparing them. Are the images exactly the same? What if not? Where are they different? What, right or wrong? Where are they different?
Right, so we can look at the actual arrangement on the page, how things are arranged, right? And talk with our students, how does that arrangement help us to understand this? Right,
and then looking over on that complex, I would, so just you guys know, the first one's usually all done for you. That's your example. And so A is my +1. And so I look at f of x equals 1, 0 to 5, or 0.5 to the x. I can't read it. My screen's too small. But whatever the first equation is, the A is the first part of the term. The base is the same as 0.5. Oh, where's there a 2? Oh, that's my H. Where's there a 1? Oh, that's my K. So now you go to the next one and they're empty. So I can use the arrangement of the first one to figure out and match the pattern to do the second problem. So now I can look and say, well, K's 1 again. And if I look at the third one, well, K's going to be 1 again. So seeing the repetition, So a lot of this, we've talked about definition and comparison a lot over the last year as to how you just learn math, but you also look at the images that are in front of you too for arrangement.
Do we want to, after we have done at the table, talk about what we have gained from this session? Is that a goal?
That'd be wonderful.
So with that, then we can hit elocution and delivery if we take turns, one or two students saying what they've gained from the lesson.
Mela, that's great, because that's exactly right. So you're saying, okay, now tell me back. So that's their memoria, right? And if you have to help them think through, right, you maybe ask them a question. And so that's modeling that idea of invention, being able to put it clearly, explaining it, they may how they order their thoughts, that it's arrangement, and then as you said, their elocution and delivery. So that's a perfect way to practice the canons of rhetoric, just sitting at the table, right? So a lot of times, as for especially for those of us who've been in lost tools of writing in the challenge years, we're very trained to think through writing this paper and including our proofs and all of these things. But anytime that we're trying to share something with somebody, right, that's when we're applying these canons of rhetoric to share our ideas with somebody else. And I just think that's beautiful. And I think that's a great goal, Melba, a great way to close out your family time at the table. Or to bring it back at the dinner table, right? So maybe you guys do math that morning and then sitting at the dinner table and dad comes home and you say, okay, everybody tell dad what we talked about at math time this morning, right? So any of those are great opportunities to practice this.
And you could even tie it back to the art. I think this one's the rabbits, and you could tie it back like, how do you think this makes a connection here? So to me,
So the rabbits is 7, 11 is
I think it's the bridge. I think it's Monet.
is this the bridge? Okay.
Yeah, because it's a function.
Oh,
shape.
the fun. Okay.
But even so, you still could do it. Which of these is like a bridge, and is a bridge concave up or concave down? And what am I even asking you when I say that?
Yeah, it's nice.
Being able to tell those stories back, right? That's pulling from your memoria, but then also your elocution and your delivery, pulling those stories out and telling those back. So we see that all of our students, right, even though we know that some students may be, we may spend more time with them on the core habits, and some students may be refining their skills of rhetoric, we, all of our students, right, when we're sitting around that family table and we're looking at our math together, all of our students can access the core habits, the common topics, and those canons of rhetoric, right, in order to learn together and have a conversation together. So notice that all of the things that we talked about, we were bringing our students together. It wasn't, oh, you go off and do yours over there, but we could start our math time by having a conversation with our students together. Or maybe you have a family that just really gets excited about the conversation, and maybe all of your math time, right, ends up being conversational, or a larger chunk of your math time ends up being conversational before your students actually complete the exercises. So I hope this encourages you all to see how we can bring our families together around mathematics.
So one thing to both encourage you and give you a realistic perspective is weeks 11, 18, 25, and 26. Those lessons are very much about analytical geometry, trying to apply functions to equations. And they're probably going to be visually the scariest of the 4 books. So as you get to know that, it might be you plan extra time, or it might be you say, this is going to be a big conversation reading week. And and with a lot of tracing. Because look, even your complex student could trace those curves. Correct. And so, and it might be so the first year through, you're just getting, it is purely touching the unfamiliar. The next year, it might be making the unfamiliar become familiar. And the third year through it, it might be we go, we're going to wrestle now. We've seen it twice. It's time to wrestle and go slow on it. And that's where, again, wisdom and homeschooling comes into place, and why hopefully within your community, you'll encourage each other to, can you imagine it's week 11 and all the kids are going to groan, and you're going to go, yeah, it makes me groan too, but we can do it. Right? We'll next, because that's what's always happened all these years. People have said, but I can't do algebra 1 or algebra 2. And we've known very well, yes, you can. There's parts of it that are very, very difficult. And let's help each other get through those. But you throw the baby out with the bathwater if you can't identify where the struggles are.
And we keep coming back, Lee, don't we, to read the example, right? Read the instructions, look at the examples, because if you notice, even in our complex, right? So it may for parents who have experienced this before, they're in that, right? This isn't my first time seeing this. I've seen this before. I don't remember it. I never really understood it the first time around. And we might immediately go, I'm supposed to be doing something with this, and I don't know what I'm supposed to be doing. But Lee just walked you through, right? All we're doing really is matching. That as we look at that, I am matching my here to my equation, right? And I could even draw lines, right? 1 matches to A, 0.5 matches to base, 2 matches to H, and 1 matches to K. And then I'm filling in blanks. So I'm not actually computing anything. It's a matching exercise, right? And so it's grammar, right? We're still loading the grammar. Eventually, our students are going to see that equation, and we're going to ask them to graph it and analyze it. But we're not doing that in complex. And so it's really important to make sure that we stop and we look at our instructions and we look at our examples, because that's what's going to help us to not be overwhelmed and to take that step back and go, oh, well, I can do this, right? I really can do this. And I can start learning, right, the grammar of what we're working through.
And what Kirsty pointed out is so true. 11 complex looks harder, but it's actually easier calculation wise than the fraction one, because all you have to do is go look at the charts and copy what the chart is if you don't know how to draw the asymptote, and everything else is a matching problem in that center. It literally is matching. So it just means you have to read it well. Versus in the fractions, we are asking them to follow 3 steps in order to square a fraction. And we only, right? So you come up with a third squared is 1/9. So you can see what I'm talking about there. So that has happened a number of times, in that the 3 quotient lessons have more calculations than the 3 real, complex, and monomials do, because those middle years need to practice calculating fractions over and over and over again more than anything else. And so we give them that opportunity. So it might be, in your case, you'd say to them, we're just doing the fractions. I don't care if you trace any of these graphs. We just need to practice squaring fractions and reading superscripts and subscripts so we can do it. So it's the flexibility is wonderful after you've been through it for a few years, but I think it's going to frustrate some people the first year, because you're going to want to get the whole page done. And we know that that's not going to always happen. And that's why we give the different skills like Kirsty gave last week, or a couple weeks ago, that look at the solutions manual and just write the answer in that. Learn how to read it from that direction if you can't calculate it. So we're going to use math, not let math use us.
All right. So as we just want to remind everybody of what we have, our rollout. So I want to point out, I've put here that digital resources are for those enrolled in 24-25. We know that they were made available for people enrolled in 23-24, but as of June 6th, that switch gets flipped between the academic years. And so if you have been enrolled and marked by your director as a member for 23-24, you've had a sneak peek of those materials. Those will go away on June the 6th, unless you have been enrolled and marked as a member by your director for 24-25. So we want to be really clear that if you are using any of the digital resources that they're just like everything that's kind of in week 7. I think people have become kind of familiar with that idea that week 7 becomes available once you've paid your tuition and are marked as a member. The Math Map resources are going to be considered a part of that week 7. And so we just want to make sure everybody's really aware of that if you want to have continual access to the companion and the digital resources, to make sure that you have gone ahead and paid and been marked as a member for 24-25. Are there any questions about the release schedule? So the other, I just missed a slide. There we go. The other thing that we wanted to take some time this week was just to remind you of the many ways that we're here to support families. When Lee and I first sat down and met about the Math Map, obviously we wanted it to be a Christian and a classical math curriculum, but she was also really eager to be able to support families and tutors well. When we're using somebody else's materials, such as Saxon, we can't create derivative products. So we can't really go out and make things that are based off of the Saxon the Saxon products to support you. But by CC owning the intellectual property rights to the Math Map, we can support you all day long, which is really a blessing both for us and for you. The first way that we're doing that is by creating the Math Map companion. That is available through CC Connected. It has a lot of information such as the who, what, why, when, where, and how of the Math Map. So some basic introductory ideas, how to tailor the Math Map, those kinds of things. Then you can actually access a digital booklet and click for more help. And not everything is filled in yet, but we are working on building this out. Right now, those booklets are available for the complex. The complex booklets are available, but everybody has access to that. So even if you have a fractions level student, you can click on those complex booklets, turn to the charts and click on a part of the chart and actually get a detailed explanation of the math where we're using more words. So some people are like, well, where's the explanations? It's all there. It's in the companion for you. We have started building out worked problems. Right now, those are only available for the top sections of pages 1 through 4 in the complex booklets. Over the coming years, there will be more of those, but we'll be building that out so that when you want to see not just the solution, but explanations for each of the steps, those will be included also. And there's also a detailed glossary, audio glossary. There's a lot of resources in there, but that's going to be your best first stop. All of our videos are linked in there. So you can, it's a one-stop shop for help for the Math Map. We also have on CC Connected, there are the forums. There's forums for Challenge A parents, Foundations parents, Essentials parents, and tutors. And I'm going to ask Babs if she'd like to just speak to those forums, because Babs and Shauna have been just amazing to me in keeping up with answering questions there. And so I think that's a really great resource when you have a question. So Babs, did you want to address that?
Yeah, I just wanted to make sure that everybody knew what the forums were, because on a couple of our director calls, I think people just thought the forums were where you could go download things that people created, but it's really a chat. Like you can ask questions and then we respond with the answers. And it's a really good place to get your questions answered. There's also a search function at the very top. So you could search, like you could search required and it would tell you, what the response we've given about it, us using it, in community for Challenge A. So you can search by little keywords. And so there's lots of questions already there that we've answered, but we'll always answer questions if we see, what you've put up there.
Great, thanks. You're here at the Math Map Book Club, so you know that we are live Wednesdays at 1 p.m. But if you didn't know, I want you to know that we have archives at leebortons.com or at Lee's YouTube channel. You can access the archives. So our first tour through The math map, as part of the book club, we went one lesson per week, and we really emphasized the exordium and some of the big ideas. The second time that we went through, we did 2 lessons per week, and we looked at pages 1 through 4 of the naturals. So it was a little bit of a different focus. And now this time we're going through it dimensionally. So depending on what you're looking for, there's going to be multiple different book club episodes that may be helpful to you. So I wanted to make sure you are all aware that they are archived and available. Then as we continue to talk about math being a collaborative subject and being something that we're inviting all of you into the conversation, right? There's that, when you're working on the same math curriculum as everybody else in your community, you can work collaboratively with other parents, right? Perhaps you are working through something and you're like, I didn't really understand that. Well, bring it to community day and talk to your other parents and say, hey, did you guys do this? Did you get this? Or how did you do that? And share what you're working on together. You can be supported by your leadership when you're using the math map. Your leaders, just as your tutors have the CC Connected forums, your leaders have access to even more support that we are offering them. And so when you go to your directors and your tutors and ask them for help, they're going to have access to support as well. And so that's one of the other blessings of using the math map is, again, that support from your community and your tutors. And then everybody can email the math map at classicalconversations.com. You can send us in errors that you find, because no matter how hard we try, we know that we've made some mistakes, and we're already correcting things. But you can certainly share those with us. You can email in and ask questions. And again, Babs and Shauna are just amazing at responding to people and answering their questions. So does anybody have any questions about the support that we have available for you or how to get your questions answered?
Kirsty, I just want to say I just got my flashcards in the mail. So they are a super resource. I've been challenged by them, but they're very, very good resource. So I would encourage people to pick up a pack and work on those, because that's an easy on ramp for the math map.
Yeah, then you'll know what a
Thanks,
base is.
Thanks, that's great. Yeah, and that's a great point, right? Especially if you are have a student who will be in Challenge A this fall, working through the naturals. We always tell everybody, work through the naturals. It's going to be your very best preparation for working through complex, but also picking up those flashcards. That notations deck especially is going to be a great preparation for being able to read the mathematics, because they're going to be familiar with those notations. So there are 3 sets that are going to be really emphasizing calculation facts. Those are our addition deck, our multiplication deck, and our fractions deck are going to be emphasizing the rapid recall of math facts. And then our notations deck is really emphasizing being able to read the mathematics. So thanks, Anne, for that reminder that is a great way to prepare for this fall. All right.
Can I
Any
ask
other
something about
questions?
Can I
Yes.
just ask about those flashcards? So I'm going through it with my son who's going into Challenge A next year, and some of the answers on the flashcards have several, things to say. So for instance, just variable X. So like, there's a couple options you can say. Should we just work on building the skill of like where he is now, and then as he continues on, we can get a deeper level, or should his goal be to get them as soon as possible? Like, what would you say to that?
So
Like
some
all the options of the answers.
Right. So so without looking at a specific card, some of those cards may have more than one option, right? So like M, for example, can mean measure, and it can also mean slope. So I would want to have them memorized, right? It's measure or slope. Some of them may have something where here's the answer and here's a little bit more information, a little bit more depth, that if you wanted to focus first on the answer and then adding in that depth, I think would be fine.
And even doing flashcards, there's wisdom in that, right? You might yank out the ones that have multiple layers of answers, and don't do those till all the rest of the deck's really done well. Then they have this really confident feeling and you slip in a new one, right? And then they have so much less to work on that time. So, yeah. At one time I was taking my grandbabies for a walk, and my older son, John, was in his 30s, and he was with me. And for 3 hours, I got those kids to hike. And he finally looked at me and said, "You are so tricky." Like, because I've just learned how to do things in little parts that make them say, "Yay, this is fun." And then give them, something else to do. And I think Andrew Pudua calls it the +1 learning,
Yeah.
right? So it's true for even Bible verse memorization.
Is there a release date for the exponents and the roots cards?
They'll be digital sometime this year, but they won't be printed till next year. Yeah. Unless Babs know. I don't know the actual date. No.
I haven't heard.
Mm-mm.
Yeah, I think it's about a year out, I think, before whenever the fractions and notations cards were released this year is about when the exponents, roots, and logs will be released next year, I think.
Yeah. Yeah, the print schedule is very similar, but I think we can go ahead and put them digitally earlier, like we did with some of the other cards. But not many people use them digitally because they don't help that much. It really is nice to have them in your hands.
That's what I was thinking. Like in the pilot, I don't think a lot of people I think they would have rather had them in their hand than to have a digital flashcard. It's just, we're accustomed to use flashcards in our hands.
Well, I always tell people online education is a really good way to get carpal tunnel syndrome and a really bad way to memorize things.
So I noticed that there were a few questions in the chat about the companion. One, yes, it is a resource we are continually adding to. We're going to be continuing to add to that for several years. Two, it is not ever going to be printed in its current form. There's just way too much content there to print. Three, it is intended really for you as a parent, so that the student can come to you and say, "Hey, can you help me with this?" And you have a resource to go to. But it is not necessary. One of the things that we got back from the pilot over and over and over again was that the books really are fully sufficient. They have everything you need to be successful each week. Because remember, we're not looking for a didactic experience where the mom says, "This is how you do it," but we're really trying to encourage our students to use their skills of learning, all right, looking at those example problems and building their grammar over time. And so that companion is really primarily for you as a parent. And so it is not intended to be a printed resource, and that includes the glossary. I will say that we do have in the works, right? And you can see here that even though we're developing these flashcards, like the print cycle just takes time, that one day we will have a printed glossary available. We are still tweaking that glossary. So even though we have like 100 pages and about 1,000 words in our glossary, we're still finding little tweaks we want to make or words we want to add. And so we don't want to print that resource and then be like, "Oh, here's another 50 words." So we're taking time to make sure that that's as complete and accurate as we can before we print that, because we're hoping that once we print that resource, and with whatever other materials we include with that, that it's going to be something that you can hold as a family resource, and not need to buy again because we've updated it. So, so those things are coming. They're not there yet. So for now, they are digital resources, but hopefully still helpful to you.
Good. All right. Well, we're out of time. Thank you again, Dr. Gilpin. It was great.
Always enjoy this time every week.
We'll see you guys next week. Bye.
Bye.